Okay, let's do another hypothesis test when we have the population standard deviation for the population mean in 9.2. Alright, so here we are. We're making sure scales are accurate. The scale that we're testing, the weight should be exactly 1,000 grams. So the population mean should be 1,000. That's what it should be. If we do this 50 times, we weigh a weight. So our sample size is 50. Read the results. Our sample mean of all these was 1,000.6. The scale is out of calibration if the reading differs from 1,000 grams. Alright, so different does not mean less than or greater than. So when we set up our null and alternative hypothesis, different is what it's not equal. It has to be 1,000. So the population mean is 1,000. It's off if it's different, which makes this a two-tailed test. So the population standard deviation is 2. So we're going to compute our test z test stat our sample mean was 1,000.6. Population mean, it should be 1,000. Standard deviation of 2, we did this 50 times. I'm going to get my numerator and divide by the entire denominator in parentheses. So 2.12 is my z test stat or statistic. So a two-tailed test my level of significance for this problem is 0.05 is split between these two tails. My critical z value will have the notation level of significance divided by 2 and be both negative and positive. For a two-tailed test at that level of significance, both negative and positive 1.96. So our test stat has to be either greater than 1.96 or less than negative 1.96. We happen to have a positive test statistic, and 2.12 is greater than 1.96. So again, we are in the critical region. That means they're wrong, we're right. We reject them. This scale is off calibration. When we land in the critical area, we reject the null. We do have enough evidence to support our claim. The scale is off calibration. We've done a lot of examples where we end up in the red zone. You don't always. If it doesn't make it to the reset red zone, we fail to reject and we are not right. The next video we're going to go over p-value for 9.2.